Today I'd like to talk about soil nitrate. We talk a lot about soil nitrate, we call it residual nitrate. Nitrogen's left over from the past crop, and a lot of times we measure the nitrate in the fall after corn harvest or soybean harvest. And that's nitrate that's available for the next crop. And sometimes they worry about maybe if we get too much moisture from harvest time or crop maturity to the next year when the crop is using nitrogen again, we may get some leaching, but in the Great Plains region, that's not really a big problem. So I like to use a residual nitrate test. So we use a potassium chloride solution. It's a 1 normal solution, which means it's 1 molecular weight per liter, which doesn't really help you understand anything, but that's what 1 normal means. And so the potassium chloride is nitrate soluble and water soluble, and we use the potassium because the potassium flocculates the clays so we get a clean filtrate. If we do a water extract, then there's some clays that get through the filter paper and you have a cloudy extract, and it's very difficult to determine the nitrate in that kind of an extract. So there's some advantages to using, in our case, 1 normal KCl. And so we shake the samples for 30 minutes to solubilize all the nitrate, and then we filter that and do the analysis. So all the nitrate that's in the soil is available to the next crop, probably down to 3 feet. And some guys that take 2 feet, and some guys that take 3 feet. Some of the NRDs require nitrate testing down to 3 feet. So it depends a little bit on how you want to do your sampling. But understand that nitrate is all available, and it's way different than some of the other elements. And the other elements are attached to soil particles and are not water soluble like nitrate is. So the nitrate we can quantify, and we do that by saying you take the depth of the soil times 0.3 times the part per million nitrate, and that gives you pounds per acre of nitrate that's available to the next crop. Very easy calculation. Now you might ask, where's the 0.3 come from? Well, if the bulk density of the soil is 1.3 grams per cubic centimeter, that means that each acre inch of soil weighs 300,000 pounds, or 0.3 million. And that's where the 0.3 comes from. So you take the 0.3 times the depth, and then it'd be pounds of soil per whatever depth of that soil is. And we take times the part per million to give us pounds of nitrate in that soil zone. Thank you for listening.